Hello everyone. The course we are doing today is the principle of remote control and program implementation. First, let's see how the Node MCU can provide a remote control function. The Node MCU itself has a Wi-Fi functionality. So let's talk about Wi-Fi first. Wi-Fi can be divided into two types. All devices can be divided into two types. The first type is AP. What is AP? It provides an access point to a wireless network. The transmission of the entire network is provided by the AP Wi-Fi. The second type is called STA. What is STA? It is the end user of the wireless network. There is also a third type, which serves the role of AP and STA. This kind of devices exist. Later during our hands-on project, we'll start with the AP Wi-Fi. We will use the Node MCU as an AP. The entire network will be constructed from the Node MCU. First, let's take a look at this. We will start with something simple for our hands-on topic. We will control the LED lights on the Node MCU. How will we control it? It will be through our smartphone. The method will be as follows. We will use our smartphone as input. The Node MCU will be in charge of signal reception and command the LED to light up. Let's take a look at this. What we are going to do next is to use the Node MCU as an AP. Our following job will be to operate the Node MCU as an AP. These are the commands that we'll be using. Let's give you a demonstration. Let's go to the desktop and open our Arduino folder. Double-click on the Arduino application. Once the program is opened, we'll click on Tools and go into the Ardu Block ESP option. Let's maximize the window. First of all, after we enter the Ardu Block ESP editing environment, we first need to set the Node MCU into an AP. We'll go to the ESP block group and select the first one, Config Access Point. This block will be used as AP setup. There will be an IP address at the back. What is this IP address for? This will be the IP address used when logging in using the internet browser to connect to the Node MCU. We can set up a unique Wi-Fi for our machine. Because if everyone uses the same SSID, which refers to the network name, then nobody will be able to log in. So everyone should have a different name. I'll name this RC66. The password must have 8 characters. I suggest that you don't change it. Keep using 1, 2, 3, 4, 5, 6, 7, 8. Once we're done with the logging setting, we'll upload this. We'll grab our controller board. Let's grab our controller board. We'll connect the controller board. I'll plug in the USB cable. Remember that the power must be turned on before plugging the USB in. After plugging it in, we can go on with our next step. We can now upload the program. Click on Save. After the upload is complete, we can take a look at this. We need to check whether the connection is complete. We'll open the serial port window. Then press the reset button on our controller. A new set of numbers will show up. This means that the name of the AP that we logged into has been established. We can set up an access point so our Node MCU becomes an AP. When you need to connect to this board, you'll need to input 192.168.4.1. Our next step is to take out our smartphone. We'll always be using our smartphone for operation. Let's take a look at this. The smartphone needs to connect to the board. We'll tap on Wi-Fi and select the AP that we established, which is RC66. We'll select RC66 and the password will be asked the first time we log in. We'll all input 1234567 and press confirm. It will connect with the board after pressing confirm. It will show that we are connected, but unable to access the internet. It doesn't matter. Now that we're connected, what is the next thing to do? Let's move on. We have already confirmed that our Node MCU has been established as an AP. We've also seen its SSID, and we were able to connect to it. What will be the next step? What we'll do next is to control the LED. Next, we'll edit this web page. When working with this web page, we need to select a switch and control the LED. Let's take a look at this. Let's go to the ArduBlock program. There is a page web editor. Inside this editor, there are several different kinds of switches. We'll first choose this switch. After choosing our switch, we need to bring out the pins. We can set it directly, so we'll drag out the pin setup block. Remove the high block and then place this in. The LED that we need to set up is at the D4 pin. We'll give this a name. We'll name it POWER. We'll give this light a power switch. Let's upload this. Once our upload is complete, we'll tap into Wi-Fi and connect to our AP. Notice that whenever we perform an upload, it will get disconnected, so we need to reconnect with the AP. Once it's done, we'll open our browser. We'll be using the Chrome browser. Here we will input the IP address 192.168.4.1 and press enter. Once you're in, you'll see the power that we set up. We tap on it and it's turned off. Tap it again. When you move this, you will see that the light is turned on. Notice that the signal we're sending right now is 0 and the LED is turned on. Do you remember why? Our LED performs a low state action, so it will activate when it's 0 and it will be turned off when it's 1. Let's also talk about another concept. Suppose we want this action to be reversed, what should we do? You may feel that having this low state action set in low is weird. It's alright, we can reverse this. In Arduino ESP, we can use a mathematical operation to perform a reversing action. We can perform a reversing action where 1 becomes 0 and 0 becomes 1. There is a not logical operation block in the test group. We'll place this in. We can then test if our signal was reversed. We'll upload this. Let's take a look at this. Whenever I perform an upload, you'll notice that the AP will get disconnected, so we need to reconnect with it. When doing so, since we have previously input the password, there's no need to do it again. Refresh the 192.168.4.1 website. Let's take a look at this. Tap on it once. When it is 1, the LED will light up. Tap it again. When it is 0, the LED will be off. This reversing action can change its high state or low state action. If you need to use in future controls to reverse it. Let's move on. Once we're finished with the light control, let's have a review. This 192.168.4.1 IP address is fixed whenever we connect to the Node MCU via AP. Let's look at the following. In our page web editor, you'll see that there are 3 different kinds of switches. We'll talk about the slider later. We have 2 types remaining. One is called switch, which we used earlier. It will choose between an on and off state and hold on to that state. The push button is different. When pressing it down, it will feedback 1, but when you let it go, it will feedback 0. The control method for these 2 is different. You can test it later and change the switch with the push button. Practice a little bit. Let's go to Ardu block, remove this, and place it on the side. In case we need it later, we can use it directly. If it's not needed, we can place it in the block area. We'll bring out the push button, copy this name directly, and upload it. Let's test out the difference between these 2. The AP will be disconnected after the upload is complete, so we will reconnect with it. Once connected, we'll go back here and refresh the web page. You'll notice that it's been changed to a push button. What is the meaning of this? When you press it, the light will be off, and when you let go, the light will turn on. It will only actuate when you tap on the button, and it will show a different state when you let it go. This feature will really come in handy later when we use it for the remote control of the autonomous vehicle. We can try it out later. You can try this out yourselves and see the difference between these 2. Once you're done, we'll move on to the next lesson. Once you're finished, we will remote control the servo next. We mentioned earlier that there were two types of switches, the switch and the push button. The next one we will talk about is slider, which can be used in servo control. The servo's angle is between 0 and 180 degrees. If we use the slider, it will have pretty good results. First, let's take a look at our servo. For the operation of the servo, you'll be given an SG90. Let's take a look at its wiring. The wires for the servo are orange, red, and brown. Let me tell you something special in here. Why do we place the positive terminal in the middle? There is a reason for that. Because if I plug the servo's wire in reverse, the servo won't burn out. After you have completed the wiring, let's keep going. We'll keep the AP setting from the last circuit. Let's go to the page web editor and bring out the slider. With the slider, we can use a sliding bar to determine the angle we want for the servo. Next, we'll go into the generic hardware group and bring out the servo block. When we bring out the servo block, we'll notice two things. We still use the D5 pin. We can take a look at this. There are different servo types. When it's sending pulses in, the width range will differ, so we can optimize it by selecting SC90. Our angle will be determined by the slider. We'll place this in. Our servo angle is between 0 and 180 degrees, so we'll set this to 0 and 180 degrees and press Enter. We will modify this and type in servo. Let's upload this. Once the upload is complete, the AP will be disconnected, so we need to reconnect with it. We're going to start with its operation. Let me remind you that the servo itself consumes a lot of power, so when we're operating the servo, I suggest that the battery box should supply the power. Before plugging the USB cable to the Node MCU, we'll use the battery box to supply the power, so that it's more stable. We'll select the AP again, because whenever we perform an upload, the AP Wi-Fi will be disconnected, so we need to reconnect with it again. Once connected, we'll go back to the web page and refresh it. You will see that there is a servo slider now. Let's take a look at this. We'll move this slider bar. Once you release your hand, the servo will move to a certain angle. We can use this method to control the servo. If we set up the servo through this connection, the servo's initial state will be at 0 degrees. We'll reset this for you to see. After I press the reset button, it will reconnect and turn to this angle. This position is its 0 angle. Of course, we can change the 0 angle by changing our rudder disc. We can take it out and adjust the position. I know that this is the 0 angle. This works as well. You just need to take out the rudder disc, reattach it, and you can decide its 0 angle position. Of course, sometimes we can only do calibration from the software because the setting of the gears was not done properly. However, from the appearance perspective, we can change the placement of the rudder disc to change the 0 angle position. Suppose I want the 0 angle position to be vertical, take the rudder disc out and place it this way for the 0 angle. You can bear this in mind when operating it. We'll let you operate on it yourselves. Once we've completed the use of the slider to control the servos, let's move on. If we want to use other servos such as the MG90, MG995, and MG996, which require more power, what should we do? We can't supply them directly with 3.3 volts. SG90 already uses it and is a bit strenuous, so the current is already unstable. So it is recommended that if you're using the MG90, MG995, MG996, or other servo models that require higher power consumption, we should use another method. What we do is we're going to take charge of the power supply. What we'll do, we'll separate the signal wire from the ones responsible for power. So we will remove the yellow signal wire. We'll show you a demonstration. Let's do this. We'll take out the servo that we'll use later. When using this, let me remind you of an important thing. The servo has a rotation range limit, so don't try to twist it if you notice that it gets stuck. It will cause the dowel inside to get damaged. Avoid this kind of action. Next, we will take out the signal wire. When doing this, we can observe this plastic shell. See the part where the plastic contacts the metal. When the metal is pulled back, it will be blocked by this small plastic piece. So I will insert the tip of the box cutter into the gap and slightly flip this up, and then gently pull out the signal wire. When you pull it out, this copper piece will not get blocked by the plastic piece, so it can be removed easily. We can find another DuPont-lined plastic shell and put it on the removed wire. Like this. Once done, we need to power these separately. We won't use the original 3.3 volts to power the positive and negative terminals. There are only 2 spots left on the Node MCU's motor control shield that can provide power. There is a VIN here, and another VIN G over here. We can only use these 2 pins to give power. Remember to cut off the power. My power is turned off. We'll use VIN for power. The signal wire should be connected to D5. Later we will see where this servo's wire should be connected. You can try it out yourselves. Next, having the slider to control the servo, what can we do? As I mentioned to you earlier, when the servo is rotating, if it gets stuck trying to get to the target angle and cannot turn over, what will happen? For example, I want it to turn to 60 degrees, but it gets stuck when it gets to 50. What should we do? It gets stuck and there is a risk it will burn out. In order to prevent this situation from happening, we sometimes choose not to use slider and use the push button instead. Sometimes we make a gripper mechanism to grab one thing only. What can we do? We can use the switch or the push button. We can set up the opening and closing angles. What angle for opening and what angle for closing. This way there is no chance to overturn. This method of operation is commonly used in gripper and lifting mechanism applications. With the slider, you may accidentally slide to a wrong angle, which may cause the servo to burn out. You can practice this part. Let's reconnect with the board. Let's tap on Finish, then refresh the web page. Since we've changed this to switch, so there will only be two angles of rotation. We need to ensure that the servo is operated in a safer way. Once we are finished, let me remind you that when you're using the slider to control the servo, bear in mind that the initial angle is 0 degrees. The same goes for push button and switch. Because we only used these few components, and the initial angle is at 0 degrees, so we recommend that you set up the initial angle at 0 degrees as the lowest angle for the mechanism motion. It doesn't get stuck at 0 degrees. Otherwise, if it activates before you have time to log on into the system and adjust its angle, the current will continuously increase at this point and cause burnout. Therefore, it is suggested that you should set 0 degrees as the system's minimum initial angle so that it will be safer. After practicing the servo control, we will perform the motor control next. Let's look at the motor control's wiring method. Please do this wiring as instructed. Let me remind you that when working with the servo or the motor, we must have the battery box powering them and should not use the USB for power. Please develop this habit. Once the wiring is done, let's move on. We'll first use the slider to control the motor speed. Before we do it, let me tell you that we will set the slider's range between 0 and 1023. However, you can test this out when you're operating later. The motor won't turn when it's at 0 to 440 range. At this range, it will make a high frequency sound, which means that there is not enough power to activate the motor. The voltage is too low. You must prevent this issue when operating this. Don't let it make this jamming sound. If this sound lasts for a long time, the motor will be damaged. When you're practicing using the slider for motor control, you must pay attention to this. Let's upload the program. While the program is being uploaded, let's have a review. The upload information will be displayed here. The information about the board and connecting port will be here. You can check these two places if any problem arises during your operation. After the upload is complete, we'll log into the AP. We'll refresh the web page. And you'll see that it has turned into a slider for motor control. So we can slide this bar, let go when you've slid to a certain angle, and the motor will rotate based on the speed you set. The higher the speed is, the faster it sounds. At a low speed, you will hear a low frequency sound because the motor can't turn, so please pay attention and avoid this kind of high frequency sound from happening. Please bear this in mind. Slide it to the far left and it will stop. It will have no power at 0 state, so it will stop. We'll move on. You can practice this. Once you're finished, we can move on to the next section. For the next part, we can now control the motor, the servo, and the LED lights. Our next step is to send feedback signals to our smartphone. What are the benefits of doing this? Later on, when we are making our autonomous vehicle, we will send back the readings obtained by the infrared sensor to the smartphone. This way, we no longer need to connect to the computer and it's more convenient. Similarly, the ultrasonic sensor can also transmit its signal to the smartphone via Wi-Fi, and we can monitor why the vehicle's motion is not as expected with our programming. Let's take a look at this. What we are going to do next is to send the readings from our infrared sensor back to our smartphone. Please do the wiring as shown in this slide. The power must be cut off during wiring. When you're done, we can start writing this program. We can remove the parts from the previous step that we don't need to use. We'll go into Page Web Editor group to bring out the blocks we need. We'll be performing and make it align. For our display, we can use We'll begin with this. Let's go to Page Web Editor and we'll look for Display Melu in the web page block. Here we can type in value, V-A-L-U-E. Press enter, then we'll bring out our pin block. We'll be getting the reading from the digital pin D6. It cannot be added because it has a different shape, so we'll go into the communication group and bring out an adapter. When it's done, we'll check this. Our pin is wrong because we are connecting it to the D6 pin. Let's upload it. After uploading, let's have a look at this. Likewise, we'll connect to this web page and then approach our finger. We will simultaneously obtain the infrared sensor's readings. It's 0 with an obstacle present and 1 when you remove your hand. This is the method. We use this transmission method to transmit the sensor signals. We can use our smartphone to observe this data. Now that we've finished explaining about the AP connection method, we'll change to using STA. For STA, we will be in the same network as the Node MCU, so we'll log into the same AP, or network. The programming for this is actually quite simple. Originally, we used config AP, but now we'll change it to config station. Of course, this should be operated at places in the classroom where the Wi-Fi connection is better. Let's perform some settings. There are actually not many changes. We'll show you directly. Let's demonstrate this once. We will remove this config block. And then we place in this config station and connect this. Type in your school's AP. Type in the password. Press enter. After that, we can upload this. Later during connection, it will automatically connect with the AP of the school or whichever environment you're in. It will connect as a station. We'll demonstrate this once for you to see. After it's done, we'll open the serial monitor to see our current status. There is no login information. When it shows this, press the reset button to reboot the system. Then it will show the login information. You can see that it's logged onto FSAP. The IP address is also shown. We can open the browser. In here, we'll key in 192.168.200.188 and press enter. You can see a new reading. When you pass your hand by, the infrared sensor will obtain a different reading. This is using the AP method. In the same manner, you can also use your computer to browse. And you don't need to use the smartphone. You can also do it this way. You can use either your smartphone or your computer for your operation. I'm currently using the computer for connection. Next, we will be performing the basic practice for this autonomous vehicle. We'll practice using the smartphone to control the vehicle to do the move and stop actions. First, let's take a look at this flowchart. We'll have the push button or the switch and choose either one of them. Later, you can test whether the push button or the switch is better. The key assertion lies in this place. Suppose we're going to use the push button. We will check if we pressed on the button. Is true or false? True means we pressed on it to allow the vehicle to move forward, and this section is executed. If the button is not pressed, then it's false. If it's false, then it will stop. When executing the stop process, there's no need to input a direction because stop has no directionality. Let's try and key in all these codes and then upload the program. Once the upload is complete, we can start operating the program. We'll connect into 192.168.4.1. We're using the push button, so we'll press it. When we do this, the vehicle is rotating. Why is it doing this? Because we set both directions to high. If both directions were set to high, the vehicle should be moving forward. So what does it mean? It means that the direction of one of our wheels is wrong, so we need to make adjustments later. When setting up the motor, we usually write the program code first, upload it to the Node MCU, then check if the motor's wiring is normal. According to that, our right wheel is correct and the left wheel is wrong. This is what we usually do. When writing our program code, we make anticipations. You can do it like this. The left wheel is 1 and the right wheel is 2. Motor A corresponds to the left wheel and motor B corresponds to the right wheel. We will write the program code based on this. This way it will be easier to write. I will say this again. Motor A corresponds to the left wheel and motor B corresponds to the right wheel. Let's fix this. Make sure the power is cut off when swapping the wires. Let's try it again. The left wheel is wrong. Check the left wheel to see if the colors of the wires inside are correct. Our left wheel is on this side, the wires are brown and red. For brown and red is the left wheel and motor A, this is correct. We'll swap this, and you can check whether your vehicle is correct. We'll unscrew this, and pay attention when turning the screw. You must use one of your fingers to slightly push down the screw. You must choose a suitable sized screwdriver because if you choose the wrong one, you can cause the screw to strip. We'll start over. We'll reconnect. Once it's connected, let's have a look. It's not connected. It's connecting. There's an error with the password. We'll input again the password 1234567 and press connect. When it's done, refresh the browser. We can test it again. If it is normal, it should move forward. Its directionality is now correct. After we are finished writing this program, we are going to review the concept of subroutines. When we were writing our program code, if we write directly like this, it actually looks quite messy and not intuitive at all. Because when these four commands are placed in, you need to think which one is high and which one is low. The writing is not intuitive, so we can use the subroutine method. There are two major advantages. The first one is that you can simplify the layout so that it looks cleaner. Secondly, we can use specific words to describe this subroutine. For example, we use move for moving and stop for stopping, which is more convenient. The second advantage is that it can be used repeatedly. Suppose this command needs to be used somewhere else, we can directly appoint it over and speed up the writing of the program, while making our program look less complicated. Let's adjust this. Let's begin. The subroutine building block is inside the control group. Let's scroll down, and you'll find the subroutine and correspond blocks. We'll drag these out. We'll need two subroutines, so we'll copy to make two. The first one will be for moving forward, so we'll name this move. The correspond block is also named move. So we can put this section that was originally responsible for the moving forward command here and replace it with the correspond block. We'll do the same for this. Move this here. We'll name this stop for stopping, S-T-O-P. The same goes for the correspond block, S-T-O-P, and press enter. You'll see that this program looks simpler and easier to understand. It will be faster to read. Let's upload the program. You can practice this part. We've completed a practical exercise, writing the program for moving and stopping. Next, we are going to control the direction of the car. We recommend that you don't write an overcomplicated program in one go. You should go step by step, so we'll only add a backwards control. We'll have them move forward, backwards, and stop functions. Don't add too many variables in one go, such as turning left and right. Intuitively speaking, it is nothing much. However, you may spend a lot of time on the program, and it will be more complicated when you need to adjust the program later on. Let's do one step at a time. Once you're more familiarized with each part, we can do something more complicated at once. But if you're a beginner, we suggest that you do one step at a time so it is easier for debugging. First, let's take a look at this. Let's take a look at these two flowcharts. Having a move forward button, now we need to add a backwards button. For the backwards button, we can take a look at these two flowcharts. Which one of these two is correct? Both have two buttons. There's a button here and another one here. Which one of these two programs is correct? First, let's take a look at this line. For this one, we'll read in the status, then press down the Move Forward button. We'll move towards this direction. Then we'll move down. The vehicle will start moving forward. You can't press two buttons at the same time. The other button will not be pressed down, so it will move towards the No section. Then it will go back. What does it mean? One is pressed and the other one is not. There will be two commands. The first one is to move forward and the second is to stop. Should it go forwards or stop? What does this action mean? This flowchart is wrong. The right flowchart is the correct one. Let's take a look at the process of the second flowchart. Likewise, we'll read in the status. We press down the Move Forward button so it will move like this. It won't have the stopping issue. If the second button is pressed down, it will go towards the second line and then move like this. If nothing is pressed, then it will go straight to stop and then move back. Right? This is the correct one. We'll try and write this program code that is correct. Let's move on to the next slide. Let me show you an example. This is our reference program. You can see that when writing this program, it's like this. We'll use if and else. We'll execute this part only for else, instead of going straight to it. This way is wrong. Because we use subroutines, the program looks simpler. You can practice this part. Once you're finished writing the program, we will upload it and check if the program is functioning correctly. Our program is correct. Unplug the USB perpendicularly backwards. Don't shake it from side to side, or it will cause damage to the USB cable. When it's done, let's go back here and refresh the web page. There are two buttons now, Move Forward and Move Backwards. The commands for moving forward and backwards are working correctly. You can practice this part and see if you have any problems. Once you're finished, we'll move on to the next section. After the forward and backward commands, what you can try to do next is a more complex one, with forward, backwards, left, right, and stop. Let's have a look. This also is written using nested if loops. Let's take a look at this. The flowchart looks like this. It's the same as the previous one and so on. This is the programming code. It is suggested that you use subroutines so that the program looks cleaner and simpler. You can practice this part. After writing the program based on the flowchart, we have added this line here. What is this line for? This line will be used to control the power output. When the vehicle begins moving towards any direction, certain parts of the program need a more detailed speed control adjustment. We can add a slider, which can be used for power output. It can be used here as well. For example, I don't want the speed to be too fast for turning left and right, so you can use this to reduce the speed when turning. You can later try out this part and add a slider here. Let's upload this once and we are finished writing the program. Once the upload is complete, we will log into the web page and refresh it. In the beginning, there's no movement at all. Why is it not moving? Because we didn't give it a power output, so we can adjust the power output and fix it in place. You can also turn the smartphone screen to horizontal. Let's take a look. We can begin operating it to move forward, then let go. Move backwards, turn right, turn left. If you wanted to move faster, you can increase the power value. We'll adjust it down. We can make detailed small adjustments. We can perform control this way. However, some of you may think that this layout is different from the usual layout we're used to, so operating it this way is a bit unfamiliar. Therefore, we will teach you the next command, which is to adjust the columns. We'll later move on and check it. You can try and operate it. This is the control screen of the program from earlier. You may think that this control screen feels a bit off to operate. What should we do? We're going to teach you the next command. We're going to make slight adjustments to the screen. There's actually only a few commands to control the smartphone screen layout in ArduBlock. We'll try to do as much as we can. At the same time, of course, you can also learn about the basics and then think of a better adjustment method. There are two building blocks that can be used. The first one is, it is only a building block to control the screen. Spacer column can control the width of the columns. The value 50 is the column's width. Lines break for increasing the spacing between the buttons so there is no overlapping. We basically have these two configurations. Let's try making a new layout with two separate rows. You can try it yourselves and see the difference. As mentioned before, we shouldn't do anything too complicated when practicing and go for something simpler. Let's try this out using the commands for moving back and forth. Let's have a look. You can try using the spacer column command to set up the layout. We also set the value of 50. However, for the if-else block, we'll place it differently. This is the first type of placement and this is the second type. What would the difference in display be? You can give this a try. Let's look at the first configuration. It should look like this. If these two sections are placed within a single spacer column, both will be arranged together and can be seen as one single row. If it's the second configuration, it will look like this. Each section is separate and placed one after another. The first section and the second section are connected. Having this concept cleared, we can move on to thinking how to configure the control layout. We have roughly redesigned the layout. You can try this out using your own ideas. If you follow our design, let's have a look. We've changed the control layout to one that we're more familiar with when moving forward, backwards, with the left and right in the middle, which is more intuitive and easier to use. However, you can add a line break block in this layout so that it looks easier to control. You can give this a try yourselves. With this, we can no longer use nested loops in our program structure because we need to separate the buttons individually. Due to this modification, the writing of our program must also be changed. This is the way we do it. When the button is pressed, it will extend the execution of the command for 50 microseconds. After executing for 50 microseconds, it will then execute a stop command. But if you press and hold it, the stop command actually is executed in a very short time and doesn't cause the vehicle to stop. What it really means is that when I remove my hand, it will execute this line. It will finish the execution of the 50 microseconds, but then it will stop. In order to solve the problem, we need to change the way we write the nested if and use this structure instead. The program will be divided like this. It will be written in blocks. You can use this as reference and practice writing the program code yourselves. If you're not used to this layout during the operation, you can include the things you've learned and write a better configuration. After we upload this last program code, let's do the final exercise. Remember to turn on the power for the vehicle to move. Move forward, backwards. Whenever you let your hand go, it will come to a stop. If we want to make a small degree rotation to the left, all you have to do is slightly tap it and let go. The same goes for the right. And then stop. If there are any problems with the motion, we can press on the stop button. Press and hold it. Then try turning left, then let go. Move forward, backwards, stop. If you want it to be faster, you can increase the value of the power. The rotation speed will feel faster. This demonstration is finished.